Well, welcome to everybody. We appreciate everybody, as always, finding the time to make the SPC monthly webinar a priority, and we greatly appreciate it. One thing I guess I haven't asked in a while, but I will throw that out to you all. Remember to give us some feedback on these things, and we do genuinely seek that. I know that obviously there are a lot of youngsters and young adults on, but also probably some parents within earshot. I will tell you that we took seriously some of the comments and feedback we received from last year and have efforted pretty strongly to adapt as we felt like it was prudent based on some of your comments and thoughts. And frequently those thoughts and comments were about how to make some of these complex topics maybe a little bit more understandable by the audience. And so that meant both having folks deliver in the message that could speak the language that would work for most of the folks on the phone call, but then also finding real world examples of how to make some of these things make sense to you all. And so tonight I'm actually really excited about the visit we're going to have here the next little bit. I say we, meaning I'm not going to do anything but sit here and listen, but I think you're going to have a privilege here in a couple moments. And before I throw it off to that, just a couple things to remember. You've received your newsletter, and so make sure you take a note to look at some of those dates. Remember that coming in April, we have that field day, and we'd really like to hear from you if you're going to come to that, if you're going to at least make an effort to. And so in that newsletter, you were requested to RSVP with us. So if you would please do that for us so that we can make sure we have an event that's worthy of you and your siblings, your parents, whomever else might come along with you. And so reach out to us on that front. Also, that newsletter also reminded you that we had some weather through here that was pretty brutal, as many of you have faced. And if you go on as of now, the current numbers for the last month are up on the SPC site at the CAP data. That all went up late last night. And so you can go and see, and you'll notice clearly that the cold weather took a toll on their ability to convert feed to gain. They still consumed a fair amount of feed. They did a nice job from a consumption standpoint, but maybe a bit more of that feed went to maintenance and just keeping themselves going in that brutal weather, and it went to just raw gains. And so take a look, dig through that data. There's a lot to mine from that, and so we appreciate you doing that and giving the feedback. So talking about mining through the data and that talk that I'm excited to hear from, I'm going to turn it over now to our newest colleague at American Simmental, and that is Dr. Rachel Endecott. Rachel's been with us now just a mere few months and has been a tremendous addition to our team. I know so many of us were excited when we heard that this might be a possibility. Then when it came to life, it was just phenomenal, not only because she's more than worthy from a colleague standpoint to lift us up, but even more her ability to interact with you all on the junior side and share some of the same things that we get to see from her as a colleague. We're all very, very excited about that. So tonight, Dr. Endecott is going to dig in on some of our actual data on some of your actual calves. And so I'm going to be quiet, and I'm going to turn it over and say, Rachel, the show is yours.
Well, thank you, Chip. I sure appreciate that. I hope everybody can hear me. If you can't, then it doesn't do me much good to say that you should chat and let us know, but I'll say it anyway. Again, good evening. I am Rachel Endecott. I'm the new Director of Youth Development and Special Projects, and we'll just jump right in. While I was thinking about this presentation, there we go. I started to think about this data diving idea, but then I thought maybe it might be a good idea to just go a little bit into some nutrition things. I'm trained as a nutritionist, so I thought maybe we might start with that. And so tonight we will get into the data, I promise you, but we're going to kind of preface that with some information about nutrition. So we'll start with ruminant gastrointestinal tract anatomy and function. We'll talk a little bit about nutrients and their requirements for animals. And then we'll look at feed intake records. Okay, so we're going to look at November and December intakes and just a sample from some of your steers. So we'll look at a few different pens and see some different feeding behavior from those intake records. And then the last thing that we'll talk about tonight, we'll visit a little bit about how feeding behavior can predict animal health. And so I'm sure all of you have pored over your SPC newsletter that Kelsey worked hard on and read through that article that we put in there. It was a Canadian research study, and I'm going to talk some more about that because it might have been a little hard to follow in some of what we put in there. So with that, then we'll have some time for questions and discussion. And certainly as we go along, this is very informal. You guys feel free to type in questions in the chat. I've got Dr. Jackie Atkins is in this room with me, and she's moderating me, so she can keep an eye on that if you have questions as we go along. So as some of you might know, beef cattle are ruminants, okay, and so that means that they have a 4-compartment stomach, and so this picture shows us a little bit about what that kind of looks like and how that 4-compartment stomach fits into the body of a beef cow. And so we can see here, you've got the esophagus where food's going to come down into the reticulum. Okay, that's here on the bottom here. Okay, and then this larger, more, the rest of this purple compartment is the rumen. Okay, then this yellow piece is the omasum, and the green piece is the abomasum. So these 4 compartments then allow beef cattle and other ruminant animals to utilize feedstuffs that those of us with a simple stomach gastrointestinal tract like us or pigs, dogs and cats, we aren't able to use those same kinds of feedstuffs. So the 4-compartment stomach is part of it, and then there's also an entire ecosystem of microbes, little tiny microorganisms that live inside the rumen, and they have a relationship with the cow that allows both the little tiny microorganisms and the beef cow to both function together. So here's just some brief looks at what those compartments look like on the inside. Okay, so if we were to look at the inside of a rumen, these little papillae, these little finger-like projections that stick out are and they're kind of made, it's called stratified squamous epithelium. So it's kind of the same setup as our skin, as human skin. And so then nutrients can be absorbed across the wall of these rumen papillae. So they have a bunch of little tiny capillaries and a big blood supply. And so they're able to take nutrients right across the wall. And the animal can use those. Okay, and so then on the left here we have what the inside of the reticulum looks like, and sometimes it's called the honeycomb stomach. So hopefully you can kind of see those shapes. So those rumen papillae that we saw in the previous slide, they are kind of fused together in the reticulum in this honeycomb pattern. And so often the reticulum is when an animal takes a bite, that's where that bolus of feed falls in there. And so say if an animal is outside grazing along and they might pick up a rock or a nail, for example, the reticulum is where often those things stay. And sometimes they can poke through and cause harm. And so we can sometimes fix that by giving them a magnet, and then the magnet then falls down into the reticulum. The nail attaches to the magnet and hopefully won't poke through. On the right-hand side of this slide, we have the omasum. Okay, so that's the 3rd compartment. And so it kind of, as you open it up, looks like leaves or pages in a book, as you can kind of see here. And so a main role of the omasum is actually water absorption. And so as feed flows out of the rumen into the omasum, a lot of water then is reabsorbed back into the body at that location. And so then finally, we would have the abomasum. I don't have a good picture here tonight, but certainly, so all of the functions that a human's stomach or a pig's stomach would perform, so does the abomasum. But because the diet of a beef cow or any other ruminant is so different from, say, a monogastric or a simple stomached animal like us, these other three compartments and the microorganisms in them are necessary in order to process the feed to a place where it can be utilized and go through the abomasum and get some value from the feed. So I mentioned that we have microorganisms inside the rumen, okay? And so there's three types. So there's bacteria, fungi, and protozoa, okay? And so here we have bacteria and fungi, okay? So you can see that these are really, really magnified, okay? So if we were to take a sample of rumen fluid and put it under a microscope, we wouldn't be able to see these bacteria and these fungi. But we would be able to see these protozoa, and so you can see that these are just magnified by 100, and so you can see those. So if you ever have an opportunity to visit a university or other research location that has maybe some cannulated animals that would have a window surgically inserted into their rumen, you can sample some rumen fluid, put it under a microscope, and you'd be able to see these rumen protozoa, these guys, swimming around in that drop of rumen fluid, which is a pretty cool thing to be able to see. So those three types of microorganisms help then the animal to digest their feed. So we call this a symbiotic relationship. Okay, so you might have heard about or have seen parasitic relationships, right? So in a parasitic relationship, only the parasite benefits, right? The host of the parasite doesn't benefit. Now, in a symbiotic relationship, both the host and the parasite, I guess, in this case, being the microorganisms, would benefit. Okay, so the rumen, in this case, provides an ideal environment for the microbes. It's a fairly constant temperature, okay, so it's going to be around 101.5 or so, the body temperature of a beef cow, okay, and there's not going to be any oxygen in the rumen, okay, and the rumen microorganisms like that environment. They don't like to be exposed to oxygen. They're called anaerobic microorganisms. Okay, so we've got constant temperature, fairly constant temperature, no oxygen, and a fairly constant feed source if the animal is consuming feed. And so the microbes then break down the feedstuff that the animal eats, and they use that those products from that breakdown of the feed to support their growth. Okay, so they're actually also, in a way, consuming the forage, for example, that a cow might graze. Okay, and then on the other hand, the products that the microbes create during the process of breaking down that feed to support their own growth provide nutrients to the host animal. And so those can be in the form of energy and protein and vitamins. Okay, and so protein, often, the microbes themselves are a really good source of protein. So as they pass out of the rumen along with the feedstuff, they can be utilized by the animal as a protein source in the small intestine. Now, one of the major products of fermentation, which is that anaerobic, no oxygen process that happens as the microbes are using and breaking down the feed, is a byproduct that we call volatile fatty acids. And so that is a main source of energy. And so we'll talk a little bit later about nutrients, and we'll talk about energy. And so the way we kind of think about them in feedstuff is a little bit different than how we think about them from a rumen standpoint. But the other cool thing about these microorganisms is that they can also synthesize or actually make vitamins. And so sometimes a lot of the, say, B vitamins are going to be made by these microbial organisms. And so we won't have to necessarily supplement beef cattle with B vitamins because of that, whereas other animals we may need to supplement. All right, so now we'll switch gears here and talk about the 6 classes of nutrients. So depending on what level of school you're at, you might have learned some of this in biology, but certainly the most important one that we can't ever forget about is water. Then we also have carbohydrates and fats, protein, vitamins, and minerals. And then carbohydrates and fats are both energy sources, and we'll talk about kind of a little bit about the differences between those and how they can play a role in animal nutrition. So we'll start with water. Okay, so as you guys know, water is a very vital piece of our dietary needs. So animals and humans do much worse, will be in trouble more quickly if they lack water than if they lack feed or food. So water is important in the digestion of feed, in transporting nutrients around the body, in getting rid of waste, in regulating body temperature. And so then we'll quickly switch here to carbohydrates. Okay, and so in the simplest form, carbohydrates are either 5 or 6 carbon sugars. So they're little molecules, they're little sugar crystals, and they either have 5 or 6 carbons in them. And starch and cellulose are 2 important carbohydrates for animal nutrition. Okay, and so they are actually polysaccharides. So that means that they're long chains of these sugars hooked together. In this case, starch and cellulose are both long chains of glucose. And so the difference between these two is that starch can be broken down by animals. We as animals have enzymes that can break apart those long chains of sugars. On the other hand, though, cellulose, we can't. We need that microbial action, okay? And so those rumen microbes that we talked about, those tiny microorganisms inside the rumen, are what's responsible for breaking up the cellulose that's in plants. Now, cellulose is going to be the major structural component of a plant, right? So if a plant didn't have cellulose, it wouldn't be able to stand up straight while it was growing. It would just fall over on the ground, okay? So you can think about it kind of like the cellulose structure is kind of like if you're going to build a building and you're going to use big metal rebar and you're going to pour concrete in around it, okay? That's kind of the same purpose that cellulose helps with in plant structure, okay? And so then down here in the bottom of this slide, we've got a little graphic. And so we can see these are these 6 carbon sugars down here. And up top, you can see that we have just slightly different bonds. And so this top line is actually amylose, which is starch. And then we have cellulose down below. And so you can see as the sugars connect in amylose, they have this same pattern here, whereas we have an alternating pattern of these bonds in cellulose. And that's the main difference between those two things. And that little tiny difference in how those bond together makes a difference in whether animals can break down that component or not. Now, fats, on the other hand, are a much more concentrated form of stored energy. And so, in fact, they're much more energy dense than carbohydrates. And so, for every pound of fat compared to a pound of carbohydrate, you'll get 2.25 times more energy from fat than you will from carbohydrates. And so we can take advantage of this in some cases. If we need to really increase the energy density of a diet, we can use a smaller amount of fat and be able to meet those caloric needs sooner. And so, as you probably know, fats can be either liquid or solid. And so some of that depends on how long the fatty acid chains are and what kind of bonds there are between them, which is not necessarily important here, but just know that we could have fats that could be in an oil form, like soybean oil, for example, or we could have more solid forms like tallow, for example, a byproduct of our beef cattle industry, being more solid fats. Now, proteins, on the other hand, we could probably do like 3 webinars just on proteins. And so this is very much a 30,000-foot view. But proteins are pretty important. They've got lots of functions in the body. And so protein needs, having those be met is pretty critical. Okay, and so protein has a function in protecting the body because hair and skin is made from protein. Proteins in different enzymes can digest feed. Also, other enzymes that are made from protein are important for being able to metabolize or use the nutrients once we get them broken down into tiny pieces and they're in the cells of the animal. There are proteins that are hormones that help stimulate growth. So for an animal, in order for your steers, for example, to grow, there are protein-based hormones that are involved in that growth process. And then our immune system is really dependent on proteins as well. So we have these big globular proteins called immunoglobulins. So they're these big blobs that kind of float around in our bloodstream, and they're always on the lookout for any kind of disease. And so those immunoglobulins are all protein-based, and they're important for keeping us and animals healthy. Minerals are also pretty important. We know a lot about mineral supplementation. Certainly the supplement that your steers are consuming and have been consuming since they entered the feedlot will have a mineral component in it. So we're going to define that as something that's inorganic. Now, when we're talking about nutrition, this is going to be a little different than when we're talking about like organic foods, for example. So when we're talking about animal nutrition, when I say something is organic, that means it contains carbon. Okay, so if it doesn't have any carbon in it, then we would call that inorganic. Okay, and so minerals don't have carbon. They're solid, they're crystalline, okay, and they can't be made or broken down by chemical reactions. So for example, if you had a sample of feed and you put it in a really hot oven and you burned it all the way to ash, okay, the ash that's left over, that's that inorganic mineral component. Okay, so that fire would be a chemical reaction, and it can't break down that mineral. It still remains as ash. And minerals are classified as they're based on the concentrations in the body. Okay, so we have a group of minerals that are found in larger concentrations in the body, and they're called major or macro minerals, and they're at a concentration of greater than 100 parts per million. And then we have, on the other hand, ones that are found in tiny amounts in our body. And those are called trace or micro minerals, and they're less than 100 parts per million. So minerals, like proteins, have a bunch of functions. So minerals are included and important components of bone, muscle, and milk. Okay, so calcium and phosphorus, important pieces here. Many of those enzymes that we talked about that are protein-based need to have a mineral involved to help them run the reactions they're involved in. And so they are called cofactors and are part of enzyme activity. So minerals are important components of two other kinds of proteins called hemoglobin and myoglobin. So hemoglobin is a big important protein because it carries iron in our blood. Myoglobin is a meat pigment. So when we go to the grocery store, or you guys go to your freezer, for example, and you pull out a steak, defrost that steak and you look at it, it's that really nice red color. That's from this myoglobin protein, and it also contains iron. Vitamin B12, so that's one of the B vitamins that we were talking about earlier that the rumen microbes can actually create inside the rumen. And cobalt is an important mineral cofactor of vitamin B12. Thyroid hormones, so these are hormones produced using iodine, and so that's why we have in iodized salt is often included in the human diet to avoid having a lack of iodine. And then in our nervous system. So in order for our nerves to fire and make muscle contractions go, we need to have minerals. Calcium is going to be important here as well. And then just regulating osmotic pressure and pH. So if you're low on potassium or magnesium, for example, those can have detrimental effects. And so having this good mineral balance is important. Some minerals can be stored in the liver, and some minerals need to be given or consumed by the animal each day. And so that's why it's often so common to see that mineral package included in a supplement, whether that's something that cows would consume on their own out in pasture, or if it's included in a diet in a feedlot ration. So then vitamins, also very small compounds, but they are organic, unlike the minerals. So these guys contain carbon. And so some animals can synthesize them, make them in their tissues, or they might use those that are made by microbes in the GI tract, which we've talked about. And so there's kind of two big categories. So we have what we call water-soluble vitamins that can be dissolved and carried around in water, so like in your blood, for example. And those would be vitamin C, and then all of the B complex vitamins. And then the other category is fat-soluble. Okay, and so these are the vitamins that are going to be easily stored in fat, and less able, they're going to have some carriers to help carry them through the blood. And so vitamins A, D, E, and K are all in that fat-soluble category. All right, so now we've kind of gone through this list of nutrients. We've talked a little bit about how they're used in how the animals' GI tracts can use those different nutrients. Now I'm going to talk a little bit about some of the diet ingredients that have been included in your steers rations at Mizzou. And so we'll start here with, so we've got wheat baleage and hay in different components. So you had some wheat baleage in that receiving ration, okay? And then as we've kind of gone into the finishing ration, we've got less of that. Now we have a little bit of hay in that finishing ration, okay? So those two would be considered roughages. And so we would consider those both, right, some components that came from plants that had to stand up when they were growing, right? So they're going to have that cellulose in them. And so that's an energy source, but we know that it's not going to be as dense as, say, starch or, say, fat. And so soy hulls kind of fit here in between, okay? And so we would call those in the nutrition business a highly digestible fiber source. So we still have a fair kind of cellulose component, but they're easier, these soy hulls are going to be easier to digest by the animal than the wheat baleage or the hay were. Now we're going to move into some more energy dense feeds, right? So we've got that corn, and so starch is going to be a major component of why corn is such an energy dense grain, why animals can perform so well on it, because we have lots of starch, it's easy to break down and provides quick energy into the rumen. It doesn't take quite as much energy to break down as these previous ingredients on our list. Now, dried distillers grains with solubles are kind of a fun combination. And so they're going to be going to have quite a bit of protein in them. So they can be provide a fair amount of protein. So probably about twice as much protein as the corn has in it. Okay. And then part of the process here with distillers, we get rid of a lot of the starch when we're, say, making ethanol, for example. But we keep a lot, we really intensify or increase the amount of fat in this byproduct. And so there's quite a bit of energy from fat in these dried distillers grains. And so that's why often we can see those animals fed DDGs perform in similar ways to animals fed corn because of that extra fat. Now remember, we said that fat was about 2.25 times the energy content in carbohydrates. And so then you guys have got some amino plus, and then you've had varying supplements, a receiving supplement, a growing supplement, and a finishing supplement, okay? And these would both provide protein, okay? Your amino plus is going to be very concentrated component building blocks. So proteins are made from amino acids, and so this amino plus is going to be focused on those particular amino acids that beef cattle might be lacking in their regular diet. And so then in your supplement, you're probably going to have protein, vitamins, and minerals is going to be your main three things that you're going to be getting from those supplements. So hopefully that gives you kind of an overview of your kind of nutritional impacts of the SPC steer diets, and then how those feed components that we've been using in those diets fit into those 6 classes of nutrients. All right, now we'll talk a little bit about how an animal grows, because that plays a role some in some of what we're seeing from the animal performance. So we've got birth over here on the left, and then we're going to have growth increasing here over time. And so we've got birth here and maturity here. We have an increase in muscle, this red line, okay? We have a slight increase in bone, but really there's not a whole lot of bone growth that happens between birth and maturity. And then you can also see that muscle kind of levels off up here, but fat, we're going to have an increase in fat, kind of a pretty steep increase as we near maturity. So how that kind of works when we think about nutrient requirements is, as cattle get closer to finish, they're going to increase the amount of fat they put on, and as a result of that, protein deposition is going to decrease. So remember, we saw that muscle was kind of leveling off in that previous graph. More energy is required per pound of fat gain than protein gain. And so as animals get closer to finish, often we'll see that they're less efficient with feed conversion because of that. And so we can kind of see how that works. You can see that if we look at dry matter intake, so the amount of feed consumed as an animal is growing, so this is for feedlot steers, increases. Now, energy is sometimes measured by a factor called total digestible nutrients, and that's our orange line. You can see that intake and energy are kind of increasing at the same pace. But crude protein really doesn't, and if we were to zoom in on this protein requirement, you can actually see there's a slight decline in the amount of crude protein that the animal needs as they increase and get closer to finish, which kind of illustrates our point of the previous couple of slides. All right, now what you really came here for. Okay, so here's our November feed intake, right? And so we can see that if we averaged the amount of feed that all of the steers in the SPC project ate over November, that would be this orange line. Okay, so if we take all of the intakes and we average all the steers over the whole month of November, we see our orange flat line. Okay, and then if we look at let's say we take each day. So I took November 1st, 2nd, well, I guess 6th, 7th, 8th in this case, because that's when we started measuring in the growth days, and we averaged over all the steers. Okay, so you can see that there's some variation, right? We've got but a gradual increase over time, which we knew as these animals grew, they would eat more. Okay, and so the green arrows show us where we switched and we made some diet changes. Okay, so then we went from receiving to growing, okay, in this first one. And then in the second one, we went from, we were mixing half and half, growing and finishing rations. All right, so then we'll move on and look at December here. And so you can see we've got a lot less variation around our monthly average, right? So the blue line doesn't have as much space between it and the orange line as it did before. Okay, so we're kind of these cattle are getting accustomed to this new place and new diet. And so we can see we had our final diet change here at the beginning of December when we switched over to that finishing ration. And so just kind of things to think about. Often when we think about feeding cattle, we think about feeding the average. And that's what we've talked about, right? And that's what you guys can look at on your spreadsheets. You can see how much did they eat, over per day over a month, or per day, like we have on our blue line. All right, so now let's look at some pens and look at some differences amongst animals, because this, I think, is really cool stuff. All right, so I looked at pen 105, okay, and so just to orient you to the graph, the orange line is how the average in November intake of that pen. So I just took pen 105, and they average just over 25 pounds a day. Then if we look at calf number 14, he's the blue line. Okay, now we kind of think about it when we feed cattle, we think about, well, we're going to feed them 30 pounds a day or whatever. Well, you can see that there's quite a bit of variation, right? Look at how much day-to-day variation there is in intake. We have these kind of peaks and valleys, and we eat quite a bit one day and not as much the next, and then we eat more again the next day. And so we'll add the other tag numbers of the calves in pen 105 on top here. Okay, and so we can see there is variation amongst the animal themselves each day to day, but look at the differences between the three colors of the three calves. You can see that there's more variation, there's higher peaks and lower valleys for some of these calves compared to others, but you can see that they're all centered around that, 25-ish pounds per day, but we have a lot of variation. So even when we think about this, we can measure this with the GrowSafe system, but this is happening even in a pen feeding situation where we're feeding in a bunk. It might not be as pronounced because there might be a little more competition factor, but they're not gonna eat the same amount every day, even though we kind of think that they should or will. All right, let's look at a few others. Oh, never mind. Okay, so now we're moving on into December. Okay, don't mind me. And so we can see this same pen and the December intakes of the three steers that are in pen 105. All right, so here's pen 106. Okay, and so we've got some steers in this particular pen that came from different backgrounds, so they're not all familiar with one another, so they came from different sources, and you can see that we might have maybe a little bit more variation and time to adjust in this group of calves than we saw in the previous pen. So we can see quite a bit of difference between, say, the pink line and the green line, and how those animals range themselves around this November intake average, that straight orange line in the middle. And we've got kind of some crazy patterns of those peaks and valleys like we had talked about. So then what happens in December? Did we kind of figure it out and get a little less crazy? And we did. We have a little more, everybody's getting a little closer to that average line, but we can still see quite a bit of difference amongst the different animals in that pen. Now, we talked about in the SPC newsletter about how feeding behavior can maybe predict animal health. Okay, and so, oh, never mind. Just kidding, I'm not ready for that. Here's another pen, pen 114. Okay, and so we've got a group of animals that have yet another and different pattern of intake. And here they are in December.
Can I ask you, we
Yes,
had
Jackie.
a couple of questions
Yes.
from the audience. I'm
Yes.
sorry I didn't see them earlier, but one question was, does it make a difference when they can eat, only one can eat at a time versus a larger bunk where they all can eat at
Sure, good question. I think that kind of relates back some to the competition thing that I was mentioning. I think that if they feel like they have to compete with their pen mates to come up to the bunk and eat, I think that is real. But there is data out there from kind of a bunk system similar to a GrowSafe kind of that we can see those same kind of differences. But if you've been to a big feedlot, even with a pen fed situation, not everybody in the pen comes up to eat when the feed truck comes by. And so it could be, that those ones that are more timid or wait till later might not get as much of an opportunity as those who are there first. But I do think that same amount of variation of eating a lot one day and less the next, we would see even in that pen fed situation.
And then we had another question about tag 2, which I think was in one of your previous slides, wondering if they got sick in November.
Tag 2 did not get sick in November, but I'm going to show you somebody who did here in the next little slide. Good segue, like we planned it that way. You guys are awesome. All right, so here's Pen 118. So if we look at tag 3, compared to 4 and 5, okay, blue line compared to the others, see, you know, before we had some variation where we had big valleys and peaks, but we didn't stay down there, okay? And so you can see here tag 3 really had a big drop in intake. And so that calf was treated with Baytril on the 26th of November, and then again with Microbes on the 28th, okay? And you can see that you know, we kind of stayed down here, and so that second treatment was probably necessary because it had impacted. And look, we made great improvements, so we kind of increased. So let's look and see what happened then in December with this Pen 118. Look at these guys. Okay, that blue line really took a little while to kind of readjust, but after that treatment early in December really was ahead of the average there, and then has gone on to go ahead and increase that intake over time. And so this kind of helps us understand how much how important it is when we have these animals that are that look unwell, that we make sure that we treat them, make sure that we can see that they're sick, get them the medicine that they need, and they can really rebound quickly. Jackie, do we have any other questions before I keep going?
We're good.
Awesome. All right, so we'll finish up here and talk a little bit about how feeding behavior can predict sickness. And so we could probably dissect the data from the SPC steers in the same way as this experiment did, but it would take more time than I had probably to prepare. But I want you to know that the technology is the same. And so we could do this if we wanted. Okay, so this was a Canadian study. And so this is the same study that was in your SPC newsletter. So there were 213 steers that they went and got at a sale barn from different sources. Okay, and so they averaged almost 650 pounds when they brought them in. And so they came in November, so this is awfully similar to another group of steers that you guys know well and are near and dear to you. And so this particular piece looked at the first 35 days of a receiving period. Okay, so the first 35 days that these steers went into the feedlot, and they were on growth safe units just like your steers. Okay, and so when the steers got to the feedlot, they got vaccinations, and they also got a preventative antibiotic treatment. Okay, so they were trying to be ahead of the game and get these guys some antibiotics to try to control any sort of disease that they might have come into contact with. And so their diets were a little different than ours because we're in the Great White North, Canada, so we can't grow many of the things that they can in Missouri. And so we had barley silage, barley grain, still had some distillers, and a supplement. And so then we had folks out in the feedlot, pen riders, that would monitor the calves. They would go through them every morning and every day at lunchtime. And so if those calves looked like they had bovine respiratory disease, now remember that you had, in December, had an awesome webinar about this exact disease, okay? And so if the pen rider said, hey, I think this calf is sick, we need to pull them, they did. And so then they had kind of a little protocol here, so that if the steers that were pulled, they went ahead and took their temperature, okay? And if their temperature was 104 or higher, they went ahead and treated them. And then even if they had a temperature under 104 but still had severe signs of sickness, so really bad snotty nose, eyes really depressed, and droopy ears, they went ahead and treated them. Now, on the other hand, if they didn't have those signs of severe sickness and they had a cooled temperature below 104, they went ahead and returned them to the pen without treating them. And so their treatment protocol was similar to your steers. At first, we went Baytril first and then New-Flor. They waited 4 days if in between treatments if there was no improvement. Okay, so how they set it up is they compared the average of healthy calves to the average of sick calves for these various variables, and they looked at the data a week before the sick calves were pulled. Okay, so they're counting back in time after the experiment is over, going back into the growth safe data to see if there were any differences during that week before that calf was treated and pulled and treated, to see if they could have predicted any sickness earlier. And so the first thing that we have here is smaller meals. Okay, so we've got meal sizes in pounds. Okay, and then days before pulling on the horizontal axis here, -7, so 1 week before on up to a day before. And so you can see the sick calves are this blue line. Okay, and so when they came to the bunk, they did not eat as big of a meal. They did not consume as many pounds at that meal when they were at the bunk than the healthy calf. Okay, and not only, and part of why they didn't have as big of a meal is they didn't spend as much time eating. And so we can see that we have a little bit of a difference in minutes. Okay, so we've got mealtime in minutes. So the healthy calves are just under 10 minutes. The sick calves were less than that, even a week before pulling, and we can see as we get closer and closer to that day when the pen writer said this calf is sick and needs to be doctored, we can see that they spent less and less time at each meal at the bunk. And so we have kind of an interesting, maybe not as clean or pretty as a relationship as the previous two. We're looking here at time between meals. Okay, so the healthy calves came to the bunk every 2 hours. Okay, and then we can see these sick calves kind of have a lot of variation during the week before they were pulled, but in general, they spent longer time. They didn't come to the bunk as often, so they ate smaller meals, they spent less time at the bunk, and they took longer breaks from coming up to the bunk. And then we have number of meals per day, so we're just right at 12 or so, or a little more for the healthy group. And again, not as pretty a relationship, but an overall trend here for the sick calves to have fewer meals throughout the day as well. So this is kind of cool stuff. And so like I said, the data that we have from Mizzou, from your critters, we could retroactively go back through and see this same kind of data. We could dig back through and figure out things like meals per day and time spent per meal. So the technology is exactly the same. So hopefully this kind of gives you an indicator of, we saw some of that from a broader perspective and a kind of a higher view when we saw that calf that was sick in November that was doctored in your study or in your group of calves, and how we could probably predict what those different feeding behaviors that led to that decrease in intake look like based on the results from this experiment. So we've flown through a lot. So you've had Beef Cattle Nutrition 101. We've talked a little bit about feed intake records, looking at some data from your cattle. And then hopefully I've kind of explained a little bit that research paper that we featured in the newsletter. And so I guess I'd open it up if Jackie's got some more questions for me on the chat. If you have any, please feel free. Would love to hear from you. And I sure hope that many of you can make it to the field day in April. Jackie and I are already planning our, I guess it's not a road trip, our plane trip to come down. So I look forward to meeting many of you. I sure hope you can make it.
There's no new questions yet, but we'll give folks a little bit of time.
Rachel, might I ask a quick question?
Maybe.
Yeah, this is.
Yes, Chip.
Stump the professor. No, so going back to the calf that you highlighted earlier that had been treated twice and how that calf rebounded so effectively in the next month. And maybe towards the tail end of that line, it even looks like maybe that calf is starting to excel a little bit. Are there any reasons that animal might get a little bit of an added bump after such a health challenge, or is it just a little bit of dumb luck or just the genetic merit of this calf? Any sense of some of the things? And I know I'm just asking you to guess a little.
Sure. Well, probably if we went ahead and looked, my guess would be if we looked at that same time period and we went back and looked at the weights, I would expect that we might have seen in November with that decline, that December weight, and some of those average daily gains might have been a little lower, but I would anticipate with this increase in intake, we would have an intake and gain that went along with that. And so often when an animal is restricted for some reason, so they might eat less because they're sick, or say we have some replacement heifers, or we're going to run some steers over the winter out on grass, and they're going to be on a restricted plane of nutrition. When those animals then receive a higher plane of nutrition, so when the sick calf feels better and starts to eat again, or when we have these grass cattle that go into a feedlot and get a higher plane of nutrition, we have a phenomenon that's called compensatory gain. And so it's where an animal has this period of efficiency where they are making up for that lack of growth or gain that they experienced during the time when they were restricted, whether it was because of that sickness or because of how we managed them. So we can take advantage of that compensatory gain and often do in our business. And we're lucky that the animals can experience that so that we can, try to make up for what was lost when we have those lost days when they're not performing as well because they're sick. We can also use that to our advantage, say in a replacement heifer development program where we might grow those heifers on a moderate or lower plane of nutrition and then start to get them kind of increasing their gains as we get closer to the breeding season. And we can do that in an efficient manner. Compensatory gain, they're going to outperform what we predict from our nutrient requirements because of this phenomenon.
So we've got a question here on the data sheet. How is feed wastage measured? And I don't know, Chip, if you want to.
Chip, can you take that one?
Sure. Gotcha. Yes, great question, and I saw that one come through as well. Essentially what we're doing there is we are looking at the weight of the feed when it's delivered, essentially via the truck, and comparing that to the weight that is consumed through the grow stage system. And if there is a differential, and it could be from birds, from wind, from calves knocking things around, if there's a loss of accountability of feed for any of those various reasons, we're referring to that as feed wastage. That is maybe a little bit of a vague terminology that the feed is going somewhere, but again, it could be from pests, wind, and again, the calves themselves disturbing that feed but not utilizing it.
So I guess I have a question on the different rations. How do they determine, okay, today's the day we're going to switch to a finishing ration?
Good question. So it'll vary depending on location. So that's certainly a good question. You guys remember that because that's something you can sure ask how feedlot management works at the field day. We can learn a little bit about how those guys go about it. But so the rumen is an environment that can adapt really quickly to different kinds of diet change. But we don't want to push it too much because we can have some issues. So if we ramp cattle up way too fast on a grain-based, high-energy, high-starch diet, we can have some negative impacts. And so one of those is known as acidosis. And so we can have some bloat and some, they're going to not feel well. We're going to see some issues with the pH in the rumen, and we're going to have this digestive disturbance. And so if we go slower in ramping them up and increasing the amount of grain in their diet, we can often be, we can make sure that the rumen has time to adapt, and we won't see those digestive disturbances. And so often it's a matter of how the cattle are performing. Various feedlots will, step cattle up over 2 weeks or 3 weeks. It kind of just depends on the cattle, how they are adapting to the diet change, and how quickly they want to increase them. Your guys' receiving ration had about, was 50% corn, and then the rest was about just under 20% of baleage, and then some supplement. And so the receiving diet, often we make that a little more energy dense than you might think for a receiving diet. Calves that come into an unfamiliar location are going to eat less amount each day, and so we want to make sure that the amount they do eat during that stressful receiving time period is high in energy. And then as we kind of go into a growing ration, we might then cut back on that energy. We want to make sure that we're promoting muscle growth. We want them to gain at an adequate rate, that we're not pushing them so fast that they start to put on fat before they're ready, before their frame has grown.
Excellent. Well, thank you. Any last minute questions? We'll give you guys a second or two to respond.
I would just encourage folks, while they're pondering this webinar has packed a lot of content in a very user-friendly fashion. I know I'll go back and revisit a time or two. I would encourage the young folks on board and some of the parents listening. I think there's a lot of content here, but it's in a way that we can all pick up on. And so I'd encourage you to maybe revisit this once it's posted at the website.
You bet. And you guys, this is my contact info. So if you have questions, if you go back through there and you have questions, if you rewatch the webinar, don't hesitate whatsoever. Please shoot me an email, give me a call. Be happy to help you out, and hope to meet many of you in April.
Terrific. Well, Jackie, Dr. Atkins, Dr. Endecott, if there's no other questions or comments on your end, I say we let these good people go and just tell them thank you. And thank you to Rachel for all of her work.
My pleasure. Have a good evening.
Yeah. Good night, everybody.